It's kit build time again. I think I will. Well, what's this one? It's right on top of the pile. Looks good. Let's do that. But first, as is tradition around here, I'll pour myself a drink so that I can get good and relaxed while I'm doing this. Tonight's beer is Nonsuch Brewing's Baltic Porter. They describe the taste as smooth coffee and chocolate notes. And it's vegan, for those who that matters to. So let's find out what this kit's all about. I'm sure it's something interesting because I bought it for this purpose. So let's see what we've got here. Got a handful of resistors, a couple of small signal diodes, a rectifier diode, switch, chip socket. What are you, microphone, speaker? Well, that's a buzzer type speaker. A little capacitor. Yeah, that's the only capacitor. A few more resistors, transistor, and a couple of chips. Oh, and some switches. So the two chips are CD4011. We've seen that recently. That is a 2-input NAND gate, and CD4066, which is another standard logic gate, I think, judging by the number, but I don't have that one memorized. The 4066 is a quad bilateral switch. Okay. 15 volt maximum for the signal, 125 ohm on-state resistance. So you can put a signal at either pin 1 or pin 2, and then when you activate the control signal, it will enable that and just connect those together. And it looks like it can work for either AC or DC voltages on that signal, so it'll be kind of a neat one to work with for like a switching matrix or something, I suppose. Oh, wow, it can handle signals up to 40 megahertz. Well, that's pretty impressive. But I don't think we're going to be getting 40 megahertz in this circuit, probably. Not if it's got a little speaker or buzzer, an audible output. Oh, yeah, and I didn't notice this before. There's a little blob chip on a carrier board, which I'm assuming slots into there like that, and we solder it down. Not from that side, though. I'm thinking it goes from this side. Yeah, those pads line up there. Okay. So whatever the brains of the operation are, that's in there, I'm guessing, and the two chips will be controlling it. So here is that little module of mystery. It drives the speaker through a transistor here, so transistors being an amplifier, really crude amplifier. I guess since that's a buzzery kind of speaker, it's just turning it on and off quickly. A few inputs here. 2 inputs coming from over here. And that's our 2 control chips. What's F1 and F2 doing? F2, F1. Those are also coming from our gate and our switch module here. And we have these switches, just the mechanical switches. These ones that are connected to ABCD. Yeah, and those are on that pin out there. And what else do they do? Oh, there's B. There's CD. There's A and B again. Oh, there's A. Okay, so these switches are setting states in the logic here. And then these guys are going... We've got 2 inputs there coming from over here. And the F1 and F2 are going to there. So it's obviously some kind of a noisemaker, depending on what's happening here. Here, and here. I'm guessing it makes different noises. I could use my phone to translate this, but I don't want to because I want to see how close to my guess I was. So let's get the board holder in and start playing with this thing. I think I'll put the blob chip in last. I think that makes sense. This slot in the board is kind of making a bit of a weakness there, so I don't want to squeeze it too hard. So, where do we start? Resistors, I guess? And the values are all labeled on the board, so I don't have to go back and forth to the schematic too much. I can just make it happen. But I guess I might as well start with, there's some 150Ks there. There's 4 of them, so that's probably these 4 that are ganged together here. Likely. Why is that diode stuck on there as well? Yeah, 150K. All right. As I've done before, I'm just going to chop these guys off their carrier tape so that I don't get any of the tape goo getting into the holes on my board. Not that it's a huge concern, but you know, try and work a little bit clean if I can here, not make it any more difficult than I need to. And away we go. Well, those are taking solder nicely. Again, this board appears to be tinned, so that is making it the heat transfer go well. Off to a good start. There's a couple of 270K resistors there and there, so I'm going to guess that that's these two. 265K, yeah, that's close enough to 270K. And those go there and here. I know I already mentioned it, but I really do approve of them putting the component values on the board. It makes constructing the circuit easier, and also if a person had to troubleshoot it without the schematic, it would make it a lot easier too, because you'd know what the component values are without any other reference material. Okay, we've got 3 other resistors here that weren't taped to anything, so again, not trusting the colored bands because colorblind me doesn't play nice with those. That one looks like about 623 or something. Okay, that will be this 620K right here. This one here is 62K, which is this one over here. And what other resistors are we missing? Oh, there's another 150K there. Let's hope that that's what this is. 150K. Perfect. So I know I've mentioned this before, but the reason I'm choosing the components in the order that I am is lowest profile first, so they're not in the way of other things, and least likely to be damaged by subsequent soldering events, which means resistors first, followed by ceramic capacitors. There's only one capacitor on here, and it looks like it sits diagonally there, which is a little weird, but I guess we'll go for it. That's this capacitor up here. It's just doing power filtering, just keeping any high frequency noise off the power line. So let's put in these diodes. We have 2 different kinds of diodes. These 2 are the small signal diodes. This is the rectifier style diode, and it is just making sure you don't reverse polarity of the power, which is always nice. These 2 are doing logic steering, maybe to make these 2 not interfere with whatever's going on over here, because there's multiple connections on everything. Anyway, there is the 4007 diode, which is the power diode, and it looks like the band is on the right hand side in the drawing, so in the silk screen rather. So I'll drop that guy in there. Yeah, the band side is connected to the capacitor, which is correct. So then we'll grab these 2 signal diodes, orient them both the same way, and find where do they go on the board. Down here. And they're both sitting the same direction on the board too. That's nice. Make sure the band is, yeah, the band's on the right side. Okay, that's good. Right, next in, I think I will put in these 4 switches. They go down here between these resistors, and I don't think they will be in the way of anything else. So is there any orientation to these? No, all the pins are in a nice straight line, so they should just drop right, there we go. Yeah, just drop right into those holes. They're not held tightly at all, so I may put some blue tack on them. Yeah, I will put some blue tack on them just to hold them in place long enough to get at least one of the leads soldered down. It's not imperative. You could just use, tape or something. You could do them one at a time and hold them with your finger, but I'm going to do them like this. And I'm just going to solder one lead on each of them initially, one of the mechanical holding leads on the frame. And then that means that they're held in place and I can pull the blue tack out of the way. And then I'll just come back and put some pressure with my finger on the back, reflow that and push it right hard against the board. And just get all the other pins. Buzzer next, I think. For polarity, it has a positive labeled up there. And there's no markings on the board. But we do know that the positive side of it goes to VCC. So that should be easy enough to find on the board. So VCC is, well, it's there, but it's also on the bar side of that diode. So is it that one or that one? It's that one. So the positive goes to that pin there, which means that goes this way. That's the first component that didn't have its polarity as clearly marked on the board. Other than that, it's been pretty good and pretty easy to find your way around so far. Now I think I'll put in the chip sockets. This one's a little bent up, but that's easily fixed. We have notches on those two ends indicating pin 1 end. And there's a notch on these sockets, so I will put them in like that. Oh wow, that one's even more mangulated than the first one. These things always have trouble in shipping unless they have them in like a box or stuck in foam or something, but they're easy to straighten out. And that one just goes up there. And again, where did my blue tack blob go? I just throw that over both of them just to, again, hold them loosely in place. I'm going to straighten them out, but I just want them to not fall out while I'm soldering them initially. Let's get the corner pin on each one. Then I can reach around the back and give it a push and reflow that solder so that the socket pushes right down. Same thing with that one. Then I can get the blue tack out of the way. And I'll come back in and pick an opposite corner, some solder on it, put a bit of pressure, reflow. There, now that one's not going anywhere. Do the same with this one down here. Pick the diagonally opposite corner to what I soldered first. There we go. Now those are tight and they won't move, and I can just get busy soldering the whole bunch of them down. Did I mention that this board takes solder really easy? It's a nice little board for something so cheap. Okay, that could have been a bridge. Everything else looks pretty good. Remaining to solder on, we have the transistor, which we might as well do now. That's just a common little NPN transistor, so I don't think it's going to suffer from any damage from working on the rest of the board. Plus, if it does, I've got tons of those little guys kicking around. So that just goes in that way. There's a little shape on the board, which makes it easy to orient. I haven't been mentioning it, but every time I pick up the iron, I wipe the crud off on my wet sponge and then give it a scrub in the brass wool, and it's nice and shiny and ready to take solder very, very readily. It's important to have a clean tip when you're soldering. Just get in the habit of every single time you pick your iron up, give it a quick clean. Us old timers still like the damp sponge method. The new hotness is this brass wool. I bounce between the two of them. Sometimes I use both, sometimes I use one, sometimes I use the other. Whatever you do, just keep your tip clean. So now about the only thing left to solder in is this little bob chip on its carrier board. And for that, I think I'm going to have to turn the board the other way around just to get at it easily. And you can see how those pads line up. So I'm guessing it solders in that orientation. I don't know what these two out here are. Oh, that one has a trace on it. And so does this one. Do they go up to those two pads on the top, maybe? Unfortunately, there's no information about this. The pads don't appear to be numbered. VCC is on pin 7, it says. Ground is on pin 2. So if we count from this one, pin 1, pin 2, 3, 4, 5, 6, 7, I don't know. Oh, that pad with the minus sign on it does line up with the capacitor. And one side of that capacitor does go to ground. So that would jive. Where is this plus? That's way over there. That's the negative, yeah. Where's the, oh, go on the positive end of that diode there. Okay, that is the positive end of the diode, right? So I don't know whether I can just splooge solder that on there. Don't know if that's going to work or if I'm going to have to put little jumper wires. Place your bets. Is this going to work? Or am I going to have to put jumper wires in? Yeah, that's on that side. Let's see what happens. It's not particularly well lined up. Yeah, that may not work. I think I am going to just have to do this with jumper wires. This is going to be another situation of how the hell do I hold that in place? Do that, and do that to hold it, and that works. Oh yeah, I'll just repeat that along there with some of my cutoff component leads and continue on again. Well, that was a bit awkward, but I've got a wire for every position. Now to get this guy down onto them. And I think what I'll do is I'll just pull these two top ones out of the way. I'm going to massage these guys around a little bit. I want it to land that way. So I want these to go through the holes this way, I think. This is going to be awkward, isn't it? Okay, I think that's got them in there. Let's bend a few of these to hold it in place, and I'm going to have to bend that back to solder them, I think, but I think I can get in there. A lot of I think I can. Start at that end, and at this end, just to hold it firmly in place. Yeah, it probably would have been a better choice to have put the leads onto the little board first and then gone to the big one. But this is what we've done, so that's what I have to deal with. You probably can't see any of this. That's okay, you're not the ones doing the soldering. It's not what I would call a beautiful thing, but it is a thing, and they are all electrically connected in the proper orientation and not short-circuited from what I can tell. So I'll just poke these guys into their positions. You know what? I think I'm going to put a bit of heat shrink on there. Just because I really don't want those to short out against the other ones. It may not be a bad thing, but since I don't entirely know what's going on this little carrier board here, we'll just be better safe than sorry. Plus, I don't get to use this super tiny heat shrink very often. I bought it thinking it was thicker, and well, it isn't, so here it is. It's only really good for using in place of spaghetti tube, which I surprisingly don't have any of. So now we'll solder those two guys in place. Maybe some of that heat will shrink down the heat shrink on the other side. Not that it matters. I don't need it shrunk. I just need it to act like insulation. It shrunk a little bit. Cool. So all that remains is to put those headers on there, which I don't really need on there. They're not serving much purpose. I think they are just providing extra inputs in parallel with the switches so you can control them externally rather than internally. I suppose I could put GPIO from something on there. So what was I rambling on about these pins? Oh yeah, I probably won't ever use them. But they're included in the kit, so I will add them to the circuit. There was no power connector included in here. It's got a provision for one, but there wasn't one, so I will just use a couple of pieces of random wire. The black will be the negative, and the yellow, yellow, I think, maybe orange, maybe yellow, will be the positive. Now just to put the two chips in. So this is the 4011. The notch on this end indicates this end is pin 1, and that dot indicates that that right there is pin 1. The 4011 goes there. This notch indicates that's the pin 1 end, which would mean that that is pin 1 there. And just like the sockets, the ICs have a little bit of bendage on their pins, but it's not nearly as ugly. So that goes in there. It's not all the way seated yet, just making sure all the pins are going in there, seated. Next, the 4066. This one only has the notch. It doesn't have a dot, but the notch tells us that this pin right here is pin 1. And of course, there's a notch on the board in the socket, which also tells us which end is which. So let's do a little bit of shipping damage mitigation here. And I think we are ready to put this guy in his house. Let's get that way. Bend that down that way. Are all the pins going where they belong? I think so. Done. Shall we see what happens when you put power on it? So I think 6 volts should be adequate. These two chips can both handle up to, what did they say, 12 or 15 volts or something like that. Why are you not going in there? These are Wego connectors. They should just go, obviously. Okay, that's in there. Everything's connected. Power. It's a noisemaker. Well, that's something. Wish I knew what was inside that blob that was causing all the noise. As suggested earlier, these two chips are buffering the switches and combining the effects on these two inputs and these two inputs here. And I could go through all of it, but it's not really going to matter too much because we have no idea what's going on inside here. But these AND gates are just combining different combinations of these switches together, buffering them, sending them either here. Well, some of them go here, some of them go here. Yeah, it's not the most clear circuit because, again, we don't know what the hell is going on inside here. But we do know what it does when we start playing with them. Different spacey sounds. And sirens and things. That's enough of that for now. I'm not sure what I would use that for. This would be a pretty good thing inside a kid's toy or something. Or a ray gun, or any of those kind of nifty little applications. I don't know, what would you use this for, other than, putting it in something for your nephews and bothering your brother horrendously? Anyway, thanks for watching. This was fun, nice and relaxing. The first kit of the month that I haven't had to fix anything after powering it on. So I think this practice is getting me somewhere. We'll see next week if a much more complicated circuit can go together just as easily, or if I'm going to have to spend hours troubleshooting it. Tune in next week and find out. Anyway, thanks for watching. Questions and comments down there. As always, if I can find a link to this kit, if you want to buy one and build it yourself, I will put that down there as well. Yeah, nothing much more to say other than thanks for watching, and I will talk to you later.